Welcome to a lesson on how to construct an altitude of a triangle. An altitude is a line segment from a vertex that is perpendicular to the opposite side. So this red segment is an altitude because it's a line segment from this vertex to the opposite side and is perpendicular to the opposite side. Each triangle has three altitudes from each vertex, and the point of concurrency is called the orthocenter. So here, point O is the point of concurrency with a point of intersection of the three altitudes, and this is called the orthocenter. Now we're going to take a look at constructing an altitude for an acute triangle and an obtuse triangle. And for these constructions, we're going to need a compass and a straight edge. So for this example, we have an acute triangle, and we'll construct the altitude from this vertex. So the first step is to put the point of the compass on this vertex and open it far enough so that when we swing an arc, it will intersect the opposite side in 2 points. And if you want, you can extend this side of the triangle. So in this example, if we swing an arc that looks similar to this, notice how it intersects the opposite side in 2 points. We have a point of intersection here, and we have another point of intersection here. Now we're going to take the compass and put the point on one of the points of intersection and then open it so that it's more than half the distance from this intersection point to this intersection point. And once we do that, we'll swing an arc above and below this side of the triangle, so it might look something like this. We want to make sure we swing them so that they would extend past what we think would be the midpoint of the segment between these 2 points of intersection. And now without adjusting the compass, we'll put the point on the other point of intersection here and then swing another arc above and below this side of the triangle. And those arcs might look something like this. Now we're going to take our straight edge and line up the intersection of the arcs here and here with this vertex. And this should be our altitude. So this red segment would be our altitude because it connects this vertex to the opposite side and is perpendicular to that opposite side. Now let's take a look at the construction when we have an obtuse triangle. If we want to construct the altitude from this vertex here to the opposite side, notice how we're going to have to extend the opposite side in order to make a segment that's perpendicular to that side. So with our straight edge, we'll go ahead and extend this side, and then we'll perform the same procedure. We'll take the point of our compass, put it here on the vertex, and then we'll open up the compass large enough so that when we swing an arc, it will intersect the opposite side in 2 points. And when we swing an arc, it might look something like this. And notice how it intersects the opposite side in 2 points. We have 1 point of intersection here and 1 point of intersection here. Next, we'll take the compass and put the point on one of the points of intersection and then open up the compass so that it extends past half the distance from these 2 points of intersection, and then swing an arc above and below this side of the triangle. So if we put the point on this point of intersection and swing an arc above and below, it might look something like this. And then without adjusting the compass, we'll put the point on the other point of intersection and do the same. Swing an arc above and below the side of the triangle. So it might look something like this. Now if we line up the points of intersection of these arcs with this vertex, it should form our altitude. So with a straight edge, we'll line these 3 points up, they should be linear, and construct our altitude. And notice how this segment is perpendicular to the opposite side here, therefore this should be our altitude. I hope you found this helpful.